This is Västermalmsverket in Falun in Sweden, a combined heat and power plant, CHP, belonging to the energy and water company Falun Energi och Vatten. Every year it provides 375 gigawatt-hours of district heat and electricity for its customers in Falun. Here too is a newly built plant for the production of wood pellets. So what has pellet production got to do with combined heat and power plants? Well, when you manufacture wood pellets, you first have to dry out the wood feedstock. This is where the wood chips are dried utilising the heat from the boiler when the demand for district heating falls away during the low season. Of the energy which leaves the CHP boiler, around 30% is environmentally friendly electricity and around 70% environmentally friendly district heating output. This means that we can produce 3 megawatt of electricity in the generator, while the wood chip dryer is utilising 7 megawatt of district heat. The chip dryer thus forms part of the district heating load and helps to increase electrical power output during the spring, summer and autumn. The dried wood material, which consists of both wood chips and sawdust, is then used as the raw material for the manufacture of the wood pellets. The pellets can be stored and used during the wintertime in place of oil, and thus represent a considerable environmental benefit. The plant is divided into 3 sections. Section 1 comprises a crusher for moist wood material. This is where the process begins. The wood chips enter the system through the roof of an intermediate store upstream from the crusher and are then fed to the crusher via 3 screw conveyors. The lighter material is separated from the heavy fraction by means of wind sifting, and the separated heavy fraction is passed on to this container by the conveyor belt. The crusher, which is provided by the Swiss company Zisor, is the first of its type in Sweden and offers a number of advantages. These include low energy consumption, ease of access for maintenance purposes, and a closed operating system with dust separation. A good example of Swiss quality can be seen in the hydraulic mechanism for raising this hatch, which allows hassle-free opening and ease of access into the crusher. The crusher benefits from a straight, upright design which ensures that during the pelletizing process, the wood chips fall naturally straight down into the machine, thus resulting in a minimum number of stoppages. The moist crushed wood material is then taken away by a small-and-type screw conveyor to an intermediate store and beyond that to the drying process. Section 2 consists of a dryer. Drying of the wood chips and sawdust occurs in a belt dryer from Swiss Combi, in which moisture measurement of the wood material is carried out at both inlet and outlet. This dryer is the first belt dryer to be built on 2 levels and is also manufactured in Switzerland. The dryer has the capacity for producing approximately 9-ton dried wood chips and sawdust per hour and operates as part of the district heating load, thereby increasing the CHP electrical output. The crushed wood chip and sawdust is fed from the dryer to an intermediate store of approximately 170 cubic meters, where the material is allowed to mature, so to speak, before entering the next phase of the manufacturing process, fine milling in the hammer mill. The hammer mill, supplied by Salmatec, also has, in addition to a coarse material separator, an inbuilt closed dust filter system. After milling down to a suitable particle size, the wood chip and sawdust material is now conveyed to a mixer equipped with paddles. And at this point in the process, water may, if necessary, be added if the material is too dry. The moisture is monitored downstream from the mixer by means of an ACO moisture measurement system. The wood chip and sawdust mixture is now fed to a so-called maturing container where, during agitation, it absorbs the added moisture and attains a homogeneous moisture ratio throughout. Section 3 comprises 2 Salmatec pellet presses. One press weighs approximately 12 ton and is equipped with 2 times 132 kilowatt motors. And from these, power is transmitted via 24 V-belts to the rotor to which the die is attached. This obviates the need for a gearbox, and the V-belts even out the forces. The wood material is force-fed into the press chamber where, with the aid of 3 roller shells, the wood chip and sawdust mixture is pressed through the die openings. This design, incorporating 3 roller shells connected by a strong steel plate, makes for high roller shell stability, a low level of vibration and quiet operation of the press. The press further has an integral vibration meter, and the temperature in the press chamber can be controlled by oil cooling of the roller shells. The press is automatically lubricated via a central lubrication system which is controlled by a PLC-based industrial computer. A further refinement is the friction clutch. In the event of any foreign material such as metal unexpectedly finding its way into the press, Salmatec pellet presses have a friction clutch. The friction clutch is triggered and the press comes to a standstill, and the rotary shaft can then be rotated back into the correct position for continued operation. When it is time for a total overhaul of the press, it will only be necessary to replace the rotor in the old housing. The lubricant reservoirs in the central lubricating system are automatically topped up with lubricant. Here at the front of the press, it's easy to take a sample of the pelleted material for purposes of quality control. Downstream from the pellet press, the pellets are fed to a pellet cooler. The air from the cooler passes a closed filter unit and the filtered dust is recycled. The pellets are cooled down from approximately 90 degrees to around 20 degrees. The pellet cooler empties out the cooled pellets onto a sieve which performs three-dimensional sieving, and the material which is thus filtered out is also returned to the pelletizing process for conversion into pellets. The sieved pellets are now fed to an outdoor silo which holds about 150 cubic meters. Here the pellets are drawn off into a vehicle below for onward transportation. The entire pelletizing plant is controlled from a central control room. At Västermalmsverket, we have created what is possibly the world's most advanced pelletizing plant, a truly clean factory, thanks to the stringent requirements imposed by our client, Falun Energi och Vatten. These requirements have meant that we have really had to pay meticulous attention to the design of this facility, and you can now see the results for yourself. We at UNY Consult and Salmatec would like to express our thanks to all concerned for the confidence which they have placed in us in relation to this project.